Yeah, hello. In the previous m- episode of risk management video, we spoke about risk categorization, risk register categorization, and the tools and techniques that is used for risk management, for risk identification, the basic types of risk like primary, secondary, positive, negative, all those things we discussed. Now we have a risk register. Now the first thing you do on a risk register is perform qualitative risk analysis. Uh, so here the inputs, if you see, we have the risk register, risk management plan, project scope statement, and organizational process assets. And then for every risk you associate it with a risk probability and impact. Both of them could be on a 1 to 10 scale, and again there is no standard for this. It could be based on organizational policies. We have our probability impact metrics, which we'll be discussing later, data quality assessment, categorization, urgency assessment, expert judgment, and risk register updates. So these things we'll be discussing as we go along. Now, for every risk, there is a probability factor and there is an impact factor. Now, this is an example of probability and impact. Now, here we are ranking it from 0 to, this must be 1, not 0.1, 0 to 1. So, higher the probability, higher will be the number. Lower the probability, lower will be the number. And there is no standard for this. It is all driven by organizational policies. Now, this is an example again. If here we are talking about if the risk, the probability scale, if it is impact, if it is 1.5, that means impact is very low. That means if the risk occurs, the impact on the project subject is minor. Whereas if it is 9.5, the impact is very high. If the risk occurs, the impact would be catastrophic and the project would be cancelled. Again, let me highlight this. These are not standards. These are just specimens to explain this. Now here there is a risk rating matrix. So here now for every risk there is a probability scale and there is an impact scale. So based on the probability and impact, we can fit those risks into any one of these cells. Now after fitting all the risk in the risk register, all these cells, maybe then you can make a call like anything 4 and above I'll manage. That means this band of the risk, will be managing. Okay, so this band of the risk we will manage. So that is that, yeah. And this white band of the risk could be under observation. That means this part could be under observation, and maybe this part for the time being I can ignore it. So we can call it as a risk rating matrix. So from the exam perspective, you'll get some questions on it. Whereas in real life, you may use this directly, or even a customized, a tailored version is fine. Thresholds is the maximum amount of risk that the organization is willing to accept on a project based on probability into impact. Now, as discussed, every risk has a probability scale and it has a impact scale as well. So sometimes we may say if the PI anything 40 and above will manage, means risk, if the probability into impact, if it is more than 40, then that risk has to be managed. Anything less than 40 need to be only under observation. So these are all policy decisions at the organization level. So based on that, you get a common behavior across managers. Otherwise, there could be somebody who is a so-called risk taker who can sit on a risk forever, even if the probability is high or the impact is high, which will end up in a catastrophe. Similarly, there could be somebody else who will highlight or escalate even small things, even if the probability is low and the impact is low. So both are not desirable behaviors by project managers. So in order to have a common behavior across managers, sometimes it is useful to define these thresholds. Now, perform quantitative risk analysis. So it's a process of numerically assessing the probabilities and the impact of each risk according to extent of the overall thing. Now here this slide is critical. So now let's assume that okay, these are risks. There is a risk A here. It has a probability factor of 10%, and that risk, if that happens, the impact is 20,000. Then the probability into impact is 2,000. We call it as expected value or expected monetary value of the risk. Similarly here for risk B, task B, probability is 30%, impact is 45,000, and probability into impact is 13,500. So that we call as a risk rating matrix. Okay, so this is yeah. So similarly here for risk C, there is a probability of 68% of it happening, and the impact is 18,000, and the probability into impact is 12,240, and we call that as the expected monetary value or the expected value of that risk. So this comes in very handy when you go for a decision tree. Is one of the quantitative risk analysis tools. Here is a decision tree. Now here we are deciding whether to create a prototype as part of risk management measure or whether we need not create a prototype. Now if you really look at this diagram till here, then okay, we get a feeling that creation of a prototype is always more expensive than not creating the prototype. Then by creating a prototype, the failure probability could be only 35%, and if that fails, the impact would be only 120,000, and if it passes, there is no impact. Similarly, if I do not prototype, then the failure probability is 70% and the impact is 450,000. So the expected value or the expected monetary value of this is 35% of 120,000, whereas here the expected monetary value of this risk is 70% of 450. So the overall cost of this branch would be 0 plus 70% of 450, which is much higher than the overall cost of this branch, which is 200,000 plus 35% of 120,000. So this is more expensive than this. So, and most probably in this case, we will go for the prototype, because doing a prototype is, if our overall cost of doing a prototype is cheaper than not prototyping. Then comes the sensitivity analysis. Okay, this is also one of the techniques or a group of techniques that may be used for quantitative risk analysis. So may not be used for small projects. Maybe sophisticated projects, they use tools like Monte Carlo analysis and all. Monte Carlo, yeah. They use tools like Monte Carlo analysis and all, where now let's say all these are risk here, and here now, so if all these are risk, now I need to, if I have to control this risk, either I should make the probability as 0 or closer to 0, or impact to 0 or closer to 0, so that P into I will become 0 or very less. So in this case now, ideally we should make one of these 0 so that the cumulative effect of the risk can be nullified. Then making it 0 could be very expensive and may not be even feasible. Example could be constructing an earthquake proof building is much more expensive than constructing an earthquake resistant building. So even if it is ideal to have an earthquake proof building, we may be okay with earthquake resistant building because the cost is going to be very high. So in our example, we need to identify the optimal values for probabilities and impacts for our risk. So first what we do is, okay, we make the probabilities and impacts of all the risk 0. Then, okay, you give a 1 comma 1 here. So based on this 1 comma 1, your activity duration, based on the values we give here, the activity durations could oscillate between their optimistic values, pessimistic values, and the most likely values. For every value you give here, you may get a project end date. So you give a 1 comma 1 here, then make it 1 comma 2, 1 comma 3. So that then okay, move on to this risk. So this cycle may go for 1,000,000 times, and it's a black box for me. So this is a statistical model. So it'll run for millions of times with the use of a computer, and it'll give me the most viable or the probable or the optimal probabilities and impacts for all the risk identified here. And this exercise is a collectively this kind of models we call a sensitivity analysis, and one of the sensitivity analysis model is the Monte Carlo analysis, which may not be used for ordinary projects. Maybe for a rocket launch kind of projects, maybe it is used, but not for ordinary projects. So from the exam perspective, if you get a question like this, okay, don't panic. Yeah. So the next is okay, so the next slide is planned risk responses. So at this stage, we have a risk register, filtered those risks based on 2 steps. One is qualitative risk analysis and then quantitative risk analysis. Now, whatever is filtered out, we get into risk response planning. So here we are talking about plan risk responses. So inputs are the risk register and the risk management plan. And here we have strategies for negative risk or threats, strategies for positive risk or opportunities, contingent response strategies. What is a contingency? Now the risk is happening. What do you do? That is contingent response strategy. To make it clear between risk response and risk contingency strategy, construction of an earthquake-resistant building is part of risk response action, whereas the instructions on what you're supposed to do if an earthquake is happening, that is an example for contingency action. So, yeah. Now, risk response planning, it talks about what are we going to do about it, ways to make negative risk or smaller or eliminate them entirely, and ways to make positive risk more likely or greater in impact. Risk response strategies could be, we have risk avoidance. Now maybe smoking is bad for health, then don't smoke it. Risk control, smoking is bad for health, maybe then reduce your smoking and increase your exercise and all those things, diet control and all. Risk transference, maybe taking an insurance is an example of risk transference. The risk is still there, but it is transferred to somebody else. Similarly, outsourcing a complex piece of work is an example of risk transference. And risk acceptance is like, I'm willing to take it. What to do? I'm willing to take it. That is risk acceptance. So people do all these things, or a combination of these things, when they are working on risk response strategies. Contingency action, as discussed earlier, the actions we take if the risk is happening, that is contingency action. Maybe as an exercise for our PMP project, you can come out with a risk register first, and then for every risk item, you rank it based on attach a probability factor and an impact factor. Then you multiply the probability factor with the impact factor. Then you come out, then that is qualitative risk analysis. Then you can, if anything 20 and above, if you can manage, I think your PMP journey would be successful. So there's a small exercise which you can do. And if there are any questions, if you have, you can post all those questions as comments under the PMP online program under PMRIcampus.com. So that way you can get your contact hours for even attending this lesson. So that is the smartest way. So if you're preparing for PMP, please do join our PMP online program at pmricampus.com, which will be very effective, cost effective, and knowledge effective, and very convenient because flexible time. And it is not just record and play. At the end of every week, there is a session with me, the instructor, for doubt clarification. So I'll strongly recommend the PMdistilled PMP online program for your PMP journey. Thank you very much.